Hello everyone, welcome back to my channel Math is Smart Tips. Today in this video we covered all the questions of GATE 2022 mathematical science and numerical questions, numerical analysis. So this video contains the full solutions of numerical analysis of GATE 2022. So let's get start the solution of these questions, and before starting the solution I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. And here in this year, that is GATE 2022, there are 2 MCQ, 1 MSQ and 1 numerical answer type questions comes from the numerical analysis. So let's start with question number 18, which is an MCQ. So the question says that the real sequence generated by the iterative scheme xn equal to xn minus 1 by 2 plus 1 by xn minus 1 for n greater equal to 1 is. Here 4 options are given. Let us suppose that the sequence xn converges to L as n tends to infinity. That means the terms xn minus 1 are also converges to L. Therefore put the value of L in xn and xn minus 1. So L equal to xn minus 1, so L by 2 plus 1 by L, this. So this is equal to 2L and L square plus 2. This implies 2L square equal to L square plus 2, and this is equal to, this implies L square equal to 2, and this gives simply L equal to root over of 2. We take positive sign here, so L equal to root 2. So there is no doubt that the sequence, this iterative scheme, converges to root 2, but there are 3 options with the conditions this. So now here we also apply the condition for the iterative scheme to be convergent. We all know that phi dash x is mod of phi dash x is less than 1. So we apply these conditions, but you can take x0 and x and so on instead of phi dash x or phi x. So here the scheme is given that phi x equal to x by 2 plus 1 by x. This is the scheme. This. So now phi dash x equal to, this means phi dash x means 1 by 2 minus 1 by x square, this is less than 1, and we can write out inside the mod 1 by this minus 1 by 2 is less than 1. So this implies minus 1 less than 1 by x square minus 1 by 2 less than 1, this. Now supply minus 1 plus 1 by 2 less than 1 by x square less than 1 plus 1 by 2. So this implies minus 1 by 2 less than 1 by x square less than 3 by 2. This and this, if we take left side of the inequality, so minus 1 by 2 less than 1 by x square. This implies x square is less than minus 2. But x square is a positive quantity which can never less than a negative quantity which is minus 2. So this is not correct. Now the another inequality is 1 by, take the right side, so 1 by x square is less than 3 by 2. So this implies x square is greater than 2 by 3, and this implies x is greater than root under 2 by 3. So this is the condition for which the iterative scheme is converges. So the correct answer is converges to root 2 whenever x0, this is an initial vector, initial approximation, so which is greater than root over of 2 by 3. So option B is clearly correct here. Now go to the next question. Question number 25. Question number 25 says that consider the linear system of equations ax equal to b with a is this matrix and b equal to this matrix, then which of the following statements are true? This is an MSQ questions which comes in GATE 2022. So to solve this question, this is clearly theorem based question or result based question. So theorem number 1, to solve this question I refer to you all the books Numerical Analysis by Jain Iyengar Jain. So its theorem says that if A is strictly diagonally dominant, matrix, then the Jacobi iteration method is convergent. This is the result, and same result holds for Jacobi gauss seidal method. If A is strictly diagonally dominant, then the matrix, then the Jacobi iteration scheme, as well as you can write as well as gauss seidal method. Gauss seidal method is convergent. So now the terms comes in this theorem is diagonally dominant. What do we mean by diagonally dominant? The diagonally dominant condition means modulus of AII, that is the principal diagonal element, is greater than summation mod of Aij, where I not equal to j. That means now the matrix is given that this A matrix 3 1 1 1 4 1 2 0 3. So the matrix A is given here 3 1 1 1 4 1, 3 1 1 1 4 1 and 2 0 3, right? Now AII means, so this element AII means 3. Now 3 is greater than, this is clearly positive element, so 3 is greater than summation the remaining two elements, that is 1 plus 1. So this is 3 is clearly greater than 2, which is correct, and similarly 4 is greater than 1 plus 1, and similarly this 3 is greater than 2 plus 0. So this matrix satisfies the condition diagonally dominant. Therefore the iterative method, both the Jacobi iterative method and the gauss seidal method, converges for any initial vector. Here one convergent for any initial vector. This is basically a theorem for any initial vector. Now there is also one theorem which is related to the iterative scheme. So which says that a necessary and sufficient condition for convergence of iterative method, that is Jacobi or gauss seidal iterative method, is that the eigenvalues of the matrix satisfies this lambda I h is less than 1. So this is clearly called the Jacobi iteration matrix. This H is called Jacobi iteration matrix, and this lambda I h, that is the eigenvalues, is the spectral radius. This lambda I h is known as spectral radius of the of this scheme. So now how to calculate this matrix H? So clearly from this theorem, the option number D, the spectral radius of a Jacobi iteration matrix is also less than 1. This is also true, since the Jacobi iteration scheme is convergence. Now we have only to check that whether the Jacobi iteration matrix is this matrix. Now to calculate this matrix H, we simply mean, so the H matrix equal to, we write simply 0 in the diagonal, and we divide the remaining elements by the principal diagonal element. So the principal diagonal element for the first row is 3. So we divide these two elements by 3, and these two element by 4, and these two element this is 0 and these two element by 3. So this is equal to 1 by 3 and 1 by 3, and now we divide the remaining two elements for row 2, second row, 1 by 4 and 1 by 4. So this is equal to 1 by 4 and 1 by 4, and this element is 0, and this element 2 by 3. So this is the Jacobi iteration matrix for this method. Now which is, so 0 1 by 4 1 by 3, but this is comes 0 1 by 3 1 by 3. So this is not correct option, is not correct option. So there the correct options are B, C and D. Now go to the next question. Question number 44. Question says that the first derivative of a function f belongs to this is approximated by an interpolating polynomial of degree 2 using the data this -1, f -1, 0, f0 and 2 f2. It found that f dash 0 equal to this approximation is given, then the value of alpha beta. Now first we take, since it is given that it is approximated by interpolating polynomial of degree 2, so we can take fx equal to 1 0 degree polynomial, or x square, that is 2 degree polynomial. Now when fx equal to 1, f dash x is equal to 0, so this implies f dash 0 is again 0. So f dash 0 equal to 0. Now we put in this form, then we get 0 equal to minus 2 by 3 f of -1, and f of -1 means here simply 1, then alpha f0 plus alpha f0 means again 1 plus beta into f2, and f2 means again 1. So this implies alpha plus beta is equal to simply 2 by 3. One condition we get. Now put fx equal to x and fx equal to x, then we get f dash x equal to 1, and now f dash x equal to 1, then this gives f dash 0 is also equal to 1, since here the approximation formula is based on f dash 0. So f dash 0 equal to 1 means this implies 1 equal to minus 2 by 3 into f -1. So minus 2 by 3 into f of -1, and f of -1 means -1 plus alpha into it is given that f0 and beta into f2. So f0 means simply 0, and plus beta into f2 means 2. So this, now this is implies 2 beta equal to 1 plus 2 by 3, sorry 1 minus 2 by 3, and this implies 1 by 3. Now this implies beta equal to 1 by 6. Now we get beta equal to 1 by 6, and we have also a relation between alpha and beta, therefore we don't proceed further to check by putting fx equal to x square. So beta equal to 1 by 6, and from here implies alpha equal to 2 by 3 minus 1 by 6. This implies 6 4 minus 1, so 3 by 6, and this is equal to 1 by 2. Now we have to find the value of 1 by alpha beta. Therefore alpha beta equal to, we get alpha beta equal to 1 by 2 and 1 by 6. So 1 by 2 into 1 by 6, this is equal to 1 by 12. So this implies 1 by alpha beta, this is equal to clearly 12. So 12 is the correct answer, option D. Now go to the next question. Question number 58 says that the initial value problem dy dx equal to fxy y at x0 equal to y0 is solved by using the following second order RK method, Rangutta method. K1 equal to this, K2 equal to this, and yi plus 1 equal to this. Now For this problem, I also refer the book Numerical Methods by Jain. So you can check the book for these solutions and more solutions of this type of question. So RK2 method is given by K1 equal to h f of xi yi, K2 equal to h f of xi plus alpha h and yi plus beta K1, and yk plus I plus 1 equal to yi plus w1 K1 plus w2 K2. Now apply Taylor series expansion about xi to this, and then comparing the coefficient of h and h square, we obtain this w1 plus w2 equal to 1, alpha w2 equal to 1 and beta w2 this equal to 1. Now comparing this star and the given iteration this star, we simply get this is w1 K1, so w1 equal to 1 by 4, and this is w2 K2, which gives w2 equal to 3 by 4. Now we put in this equation, so alpha into 3 by 4, this is equal to half. This implies alpha equal to 1 by 2 into 4 by 3, which gives 2 by 3, and similarly beta equal to 2 by 3 by putting this. So we get the value of alpha and beta. Now we have to find simply alpha beta. So alpha beta equal to 2 by 3 into 2 by 3. This gives 4 by 9, which is equal to 0.4444 so on, 4444 so on. So round up to 2 decimal places, the answer is 0.44. So this is the correct answer for this problem, question number 58, and this is the last questions of numerical analysis. So how was the video? If the video is helpful, then please give a like to this video, share with your friends and subscribe the channel. Thank you friends, see you again in the next video. Thank you.